Welcome. Let's have a little discussion on the topic sine rule under trigonometry 2. You are conversant with the Pythagoras theorem when we are asked to find missing side or any angle. Let's say we have A, B is given in value and the C is not given. We can use the Pythagoras theorem to arrive at that. We also know that if an angle is introduced and one side is given, we can be able to find all other sides very easily. Now, this is possible using the sine rule, using the trigonometry ratios, which is the sine of the angle, the cos of the angle, and the tan of the angle as a ratio, because it is a right angle triangle. Have you ever wondered if the triangle given to you is not a right angle triangle, how we are going to find missing side and missing angle? For example, if I give you here as an acute angle of 65, given here as 7 centimeter, 3 centimeter, and we are asked to find A. You can see that because it is not a right angle triangle, Pythagoras theorem will not work. Neither will the trig ratios also have their take on this. That is where we deal with the sine rule, developing another formula that can be used when these properties fail. So let's see into that. Okay, so let's see. If we have been provided with a triangle like this, either drawn by ourselves or provided in the question, and we are asked to find other sides. Let's just say we have A is here, opposite here, to give us the side opposite to A. B is here, opposite here, then here will be C. Now, when I am asked to find any of the sides, it will be difficult to do. So let's have an introduction of a height or a line which will be perpendicular to the base. If this line is perpendicular to the base, it divides the triangle into two equal parts. Two parts, not equal. And these two parts all have a right angle. So this is going to be, let me take care of this and put here D. So I'll be having two triangles. This is going to be the height of the first triangle ACD and the height of the second triangle BCD. These are all two right angle triangles. So if I want to introduce an angle here, then using the sine, I am referring to sine. So the sine of the angle, let me just put A, is going to be the opposite side, right? We know so. So we are picking the opposite side, which is h, divided by the hypotenuse, which is the side facing the right angle box. So this gives us B in terms of the ratio of a sine. We are introducing the h. So let's make h the subject from here. So if you make h the subject, h will be equals to B times the sine of what? A. So we have the value of that here. Now let's also say we have this angle introduced here. If I have that, I can say that the sine of the angle will be equal to the opposite side h over the hypotenuse, which will be A. What do? We can also cross multiply. H will be equals to A sine B. So you can see H in the first side is having the right. H in the second side also have the right. So we can equate the two. So in this case, we can say that H equals to H implies that B sine A will be equals to A sine B. You can see these two terms are multiplying. So we can be able to write a ratio out of that, right? Good. So if we divide both sides by B, we can divide both sides by B. We can also divide both sides by sine A. So let's see. Divide both sides by sine A. That means I'll have B sine A divided by sine A sine B divided by sine what? A. So if it cancels, you'll be left with B equals to A sine B divided by sine A. So now let's divide again. By the sine B. We are dividing by the sine. The A first, then the B. This is a fraction. So if we divide it by sine B, we can change this to multiplication and we find the reciprocal, right? And you can see numerator, denominator, it will cancel. So we will be left with B divided by sine B, A divided by sine what? A. So this is what we are going to be using as a ratio. It could be B, the side, divided by the angle facing the side. The sine of the angle facing the side equals to A divided by the angle facing that side. The same way, if we were to introduce a line from A towards BC, dividing it, it will also provide two right angle triangle, which when we follow through the same procedure, we will have this to be C divided by the sine of C. These two is a ratio, these two, and so on and so forth. So this becomes the sine rule. The sine rule. If you are asked to find, if two sides are given and an angle, you wanted to find the other one, we use this connection. Make sure the side that is given to you to find should have an angle corresponding to it. You see, if I have this direction, let's take a question and check. So let's look at this. We have to find the side label A. Look at it carefully. Two of the angles are given and one side is given. The side we are asked to find is having a corresponding angle. That is the content. That if it is an angle we are asked to find, that angle will have a corresponding side given to us in terms of value before we can be able to find the missing side. So in finding this, we can just say that solution using the sine rule, we know we begin with what we are looking for. A, the side, then the sine of the angle 118 equals to, we were given 7, then the sine of the angle 39. If we are asked to find the angle, we can also follow the same procedure. We are going to do cross multiplication, meaning A sine 39 equals to 7 sine 118, right? So we divide by the sine 39, meaning A sine 39 divided by sine 39, all in degrees. Yes. Then that will be equals to 7 sine 118 degree divided by sine 39 degree. You know the sine will cancel, giving rise to A, and that will be equals to 9.82. What are we using? Okay, no, the meter. Don't forget 2 decimal places. So you can see in using the sine rule, what we are interested in is the fact that the triangle is not a right angle triangle that will call for the use of Pythagoras theorem or the trig ratios directly. So we resort to the use of the sine rule. When two sides are given with an angle which is corresponding to find, when these two are given, this angle could also be missing and this side will be given, whereby we can find that. I guess we are good to go. Thanks for following. Like, share, and comment. Come back. Let's take a question again, showing different aspects of it and the cosine rule. Bye-bye.